Welcome to the beginning of our study together. This will be Unit 1. We'll shoot 3 separate videos as we look through the content in this first PowerPoint. You'll be able to find the entire PowerPoint in the resources folder for Unit 1. So you can pull it down, click slides at your leisure, grab a Diet Coke, grab a bag of Doritos, and you can take a look at the content and the examples in a time span that suits your needs. So we'll notice on the front slide here that it looks like the material from this first unit comes from Chapter 4 in your textbook. So you're certainly welcome to open up the text at any point in time and follow your author's approach. He's got some pretty good examples. It's not a bad book to follow. Later on, there's some things I kind of don't like, but for the most part, I think it's a pretty decent text. So what you'll see as we open this PowerPoint is we've got an overview in terms of what we're going to look at in the unit. Nothing in this first unit should be or unlearned from previous experiences. A lot of what you're going to see here, you've gone all the way back to pre-algebra, the notion of solving equations and solving word problems. We'll finish out the unit with a look at proportions, and most of you probably remember the phrase cross multiply. Served you pretty well in the past, probably still will. So with no further ado, let's begin the section and take a look at what's going on. For each of these PowerPoints in terms of introduction, you'll see I listed a set of objectives that we should master as the unit gets processed. So hopefully by the end of Unit 1, we'll see some objectives from sections 4.1, 4.2, and 4.3. Again, I'm not going to read them to you. You can certainly pull the PowerPoint down and take a look at them in a slower, more concise fashion. Look, I know most of you in the past haven't heard word problems and jumped up and down and said, oh yeah, can hardly wait. And part of that's the fault of us as instructors. I think sometimes we don't give you enough time to process the content well enough to develop a sound understanding before we launch into another kind of problem. And that's on us, frankly. It's not your issue. It's the issue of us as instructors. So we're not going to do a lot of crazy problems. We're going to look at the notion of some very basic things. But I got to be honest with you, I think that you learn algebra so that you can attack problems in a logical fashion. So even though early on in this first section, the goal is simply to solve an equation, rest assured that by the time we get to section 2, word problems are our focus, and then we'll take things up and kick it up a notch. All right, welcome, section 4.1. You and I are going to solve equations. Again, nothing new here that you haven't done in the past. So let's take a look at some processes that'll help us. All right, I'm not one of those teachers that says memorize this. It'll be the first question on the test. But basically, it's the general look for an equation. You got at least one variable term, maybe a couple of constant terms. And you and I have mastered the processes of being able to move variables to one side and being able to move constant terms to the other side. And that's really what we're going to wind up having to do as you and I solve our equations. So you know that we can do all kinds of things. We can add something to both sides and not wreck the equality. We can multiply both sides by some number and not wreck the equality. We can subtract something from both sides and again, maintain the equality. And last but not least, we can divide both sides of our equation by something as long as that something's not zero. We're never going to be savvy enough to divide by zero. It's an undefined deal. I like this slide. It gives you a step-by-step checklist of ways that you can attack equations. Basically, be sensitive to distributives. You got to take care of groups. Some of you remember PEMDAS from back in the day, the old order of operations ideas. So grouping's pretty high on that operations list, so we're going to have to take a look at that as we go. But again, you can read this thing section by section, get you a look. But for me as a solver, the notion is we want to clean up the clutter first before we start deciding who to move, left side, right side. First example's up and firing. Looks like all we've got is an opportunity to combine some terms on the left side. So we'll add the 5x and the negative 2x, and that gets us to the first step of this solution. And then really all that remains is to move the 3 out of our way. So we've got x's clustered to the left side. We get that 3 out by subtracting on both sides, and a quick divide by 3 takes us out of here. So it's an easy example. There's not a whole lot of heavy stuff going on. Just make sure that you realize that first we got a chance to combine before we start thinking about moving things side to side. Problem 2, welcome, distributive, showing up. You and I are going to distribute. So the negative 6 is going to hit everything on the left side. The 3 is going to hit everything on the right side. So just make sure the negative 6 affects both the x and the 1. And on the right side, the 3 affects both the x and the 4. So there's your first step coming at you. That's how we get to the negative 6 minus 6. That's how we get to the 3x plus 12. All right, now you do have variables both sides. So the first thing I think we should try to do is decide whether we would rather move the 3x or whether we would rather move the negative 6x. A lot of times I move the guy with the smaller number part. So a lot of times I would move the negative 6x. It gets you less negative stuff. And for me as a solver, that usually meant better things. Less negatives was a good thing for me as a kid. This time I'm going to fake you out. I'm going to move the 3x. So I subtracted 3x from both sides, and then I added 6 to both sides. And that's how the negative 9x showed up. And that's how the 18 showed up. Quick divide by 9, and this baby's out, and x is negative 2. So you're going to find out that we got a distributive right up front. We got to move things side to side, and nobody seriously got hurt. Third problem looks like a couple of distributive opportunities, probably a chance to combine some like terms, and then the notion of what we're going to have to do to move. So let's go. Let's get it. All right, 3 times 2x is 6x. 3 times negative 4 is negative 12. 3 times x is 3, and 3 times 1 is 3. Good stuff. Left side, let's combine the 6x and the 3x. Please note, we don't have to move anything to do that. There's no idea here of subtracting 3x. Those terms that we're combining are already on the same side. So we're going to get a 9x by combining them. We're going to get a negative 9 if we combine the negative 12 and the positive 3. Next step looks like move that 9 out of there, move that negative 9. So we're going to add 9 to both sides. And the last, a quick divide by 9, and we're out. So I should tell you as the teacher, and I'm bad in that I don't do it. I'm a typical egotistical solver. I did it, so it's right. If you take the time to put 3 back into your original equation and you do the arithmetic on the left-hand side, if you turn out with a value of 18, you know your answer is correct. So it's always worthy. All right, I'm not a solver and a checker. In fact, as a kid, that bothered me a lot when they made me check. This one's got more of an attitude. You got multiple groups on the left side edge. First of all, remember that negative leading a group wants to change signs on everything inside that group. So let's take that first, all right? So we're not going to get the distributives involved just yet. We'll take that negative, and it changes what used to be an x to a negative x, and changes what used to be a 2 to a negative 2. And then if I'm solving, I'm going to go ahead and I'm going to clean up the terms inside that bracket set. So 6 minus 2 is going to become a 4 for us. And I'm going to do that before we get the distributives moving. Now we'll distribute on both sides. We'll distribute the 3. We'll distribute the 4. Don't lose that negative 6. It's part of what's going on, but it's not part of your distributive attack. Okay. Looks like on the left side, we can combine the 12 and the negative 6. We should do that. And then we'll start thinking about what we want to move. Oh, that's a cool arrow. All right. Here's that negative 12 and 6 combo. That's how that 6 got there. Then the negative 3x. And on the right side, you got your results of negative 4x plus 28. I know what you ought to do is probably just add 4x to both sides, and then we should probably subtract 6 from both sides. So there's the impact of adding 4x to both sides. Here comes the impact of subtracting 6, and you guessed it, man. We are finished. So again, a pretty clean solution at the end of all that. Inside group first before you get to outside group. You should be okay on example 4. The last 2 examples we'll look at in this video are examples of equations that feature fractions and decimals. For most students, I think fractions are more of a pain in the neck than decimals are, simply because your calculator handles decimals pretty well. Your calculator may or may not handle fractions as well, because not every fraction turns into a clean terminating decimal. So you're going to find out my approach to solving problems that have fractions in them is to multiply by something to make the fractions clear out. And it's not rocket science. You're just looking for a common multiple. You need a number that both 3 will divide into prettily and that 4 will divide into prettily. And the best example, I think, for us on this one might just be 12. You could use bigger, but you don't get bonus points. So there's the impact of multiplying both sides by 12. I thought it was really cool to add that impact by making it pink or chartreuse or whatever the heck that is. So on the left side now, you want to focus on 1/12, on that 12 times 1/4, and 4 goes into 12 3 times. So that's going to clean out that fraction. And on the right-hand side, 3 goes into 12 4 times. So that's going to clear out the fraction on the right-hand side as well. And we're going to get something that looks like 3 to distribute on the left, 4 to distribute on the right. And we're going to be okay. We're not scared now. There's your distributive impact, 3 times x, 3 times negative 2, 4 times 2x, and 4 times 6. All right. Oh, another cool arrow. Let's move the 3x. Yeah, why not? So we'll subtract 3x from both sides. Then we're going to subtract 24 to move all the constants to the left side of that equation. So let's do that. Quick divide by 5, and this baby's out. And we get another answer at x is -6. One more to go as we finish out our first video from the first section of Unit 1. And this guy's got decimals. You could keep them. Your calculator isn't horrible with decimals. It'll handle things pretty well. So if you're a decimal fan, keep them. If you say, geez, I wish that was an 11. I wish that was a 2 instead of a 0.02. We're going to multiply by 100, a power of 10, big enough to move that decimal 2 spots to the right. So that's your beginning. There comes the impact of the 100 coming in to affect both sides. Be careful. You've got 100 to impact 2 particular quantities, the 0.11 times x minus 4, and again to impact the -0.05. Same thing on the right-hand side. You've got the 100 having an impact on 2 locations. This next slide, the next click, shows you that pretty well. So on the first thing to consider is the 100 times 0.11 is your goal. That's 11. That's going to get us to something good. The 100 times 0.05, that's good too. That's 5. 100 times 0.02 is going to get us a 2 to distribute, so that's pretty cool. Be careful on the 100 times 0.3. That actually turns into 30. Make sure you don't make that a 3. So there's the results of multiplying by hundreds. Cleans out the decimals for us quite effectively. Now you got distributives to run. Again, we've played this song before. 11 times each of the x and the -4. 2 times the x and the 10. Combine like terms? Sure, why not? Oh, that's an interesting arrow. All right, so we combine -44 and -5. That got us -49. If we combine 20 and 30, that's going to get us 50. We'll now subtract 2x from both sides, and then we'll add 49 to both sides. And then, that's going to get us a clean divide by 9. This baby's out. And that finishes our sixth example from Section 1. It also wraps up the content in Section 1, where we focused our energies on solving equations. We'll see you back here soon for Section 4 too, where word problems take off. All right, see you soon.